Hello students, Dr. Wang is here. In this episode, I'm going to teach you how to use your financial calculator to do some statistical calculations. And in particular, we're using TI 84, 83, or 82. The models does not really matter as long as you have this statistical function on your calculator, that is fine. So I have two exercises for you here. One is about a scenario-based calculation. So we need to calculate the expected return as well as a standard deviation based on different scenarios. So that's exercise number one. And exercise number two is about getting the standard deviation based on historical data. So we have different years instead of different scenarios. And again, we're getting the risk characteristics, which is measured by the standard deviation. Alright, so let's just move on. How can I get the standard deviation of a certain asset or certain property? So let me just look at these assets. It is rate of return for a stock. Under different scenarios, you may have a weak economy, below average, average economy, above average, and a strong. And each kind of economic condition would come with certain probability. You have a 0.1 for 10%, 0.2 for 20%, 0.4 for 40%. Okay, so the returns are a negative 50%, negative 5%, so on and so forth for different economic condition. For now, please ignore this column. It's the return offered by the T-bill, which does not change over years or across different scenarios. Okay, so this is your data to analyze, and this is probabilities. Okay, so how do you get a standard deviation? If you follow the mathematical formula, you have to get the expected return using each of the probability times each of the return to get one product, and then you're going to sum up all the 5 products together to get expected, and then you're going to use this individual return subtracted by the expected to get a deviation, take a square to get a square deviation, and then times the probability, then add them up, and then take the square root. Okay, so that's going to be a very long, tedious process if you follow the mathematical formula. So if we do using a calculator, this is what you do. First of all, I want you to hit the Stat button. Alright, so hit the Stat button and you will see different options for you. And you just hit Edit. Okay, just hit Edit. And then you will see L1, L2, all the way to L5. So basically, these are the columns you need to put numbers in. And for L1, you can put this probability column. So remember, if it is a 10% probability, we're going to put a 0.1. So 0.1 for 10%, all right, and then 0.2 for 2%, 0.4 for 40%, and then 0.2 for 20%, 0.1 for 10%. All right. So make sure these are in numerical format when you are dealing with a probability. Do not put 10 for 10%. Do not put 20 for 20%. You put a 10. You put a 0.1 for 10%, 0.2 for 20%. All right, and then you move to the next column. Just hit the red arrow. Then you have L2. It is okay this time to put a negative 50 for 50% because these are all percentage return. If you put a 0.5, that's also okay. The thing is, you have to do this calculation in your brain to convert 50% to 0.5, convert 16% to 0.16. That's just some work, which is not necessary. All right. So if you put a negative 50, that's fine. And the result will be based on this 50 at the same magnitude. Alright, so negative 50, then negative 5, then 16, okay, then 25, then 60. Okay, so now I have finished input all the numbers, and then I need to do analysis. I'm going to hit the Stat button again, very important, Stat. And then this time I need to move to the right and select Calculate. Okay, CALC standing for calculation. I want to hit one variable stats, although I have put 2 columns data, but still just one variable, which is rate return right here in this column. and the other column is just a probability attached to it. So just hit one variable stat, hit enter. Alright, the list here is actually wherever you put your rate of return. It's not in L1 because in L1 you put the probability. That's for the frequency list. For the list of the variable, it is actually in L2. And how do you select L1 or L2? You see the buttons here, number 1, number 2, and on the top you see L1 and L2. Alright, so in order to select L2, you have to hit a second button and then number 2. Alright, so that's how you select this blue icon. And then you move down. Then for the frequency list, you select L1. Just hit a second 1. And then you will hit enter to calculate. So right here, you got all the results you need. X bar is the expected return based on the probabilities and the payoffs or returns under different condition. And sigma x is the standard deviation we're looking for. It is at 26.69. Alright, so just use your calculator to verify this number. You also have another column data here. It is the T-bills rate, which is the risk-free rate. As you can see, it is always 5.5% across different economic conditions. So no matter what happens, the T-bills offers 5.5% return. If you want to calculate standard deviation of it, you just have to follow the same step. So let's just do it. So I'm going to hit the stat button again, and to edit, just hit enter. And then I rather put this column data in L3. Alright, so just move to the right, and then I'm going to put a 5.5, 5.5, 5.5 over and over again. 5.5. Alright, so I put all these T-bill returns for different economic conditions, and then I'm going to hit the stat button again, and then hit the calculate again. Still it is one variable stats, although I have 2 columns of data. So for my list of the variable, it should be this 5.5 wherever I put it. So since I put it in column 3, so I'm going to use second 3 to get L3. And still I put the frequency list as L1. So I move down and then calculate, hit enter. Alright, so what you see here is the expected or the average, weighted average of this column data is 5.5. Well, it's pretty obvious that it has nothing change when economic condition changes. Alright, and the standard deviation here is actually 0. Alright, as you can see, there's no risk at all. There's no deviation from the average whatsoever, so the risk is 0. Alright, so this is an exercise based on different economic scenarios. Once again, if you hit the stat, hit edit, then you will have to put a column of probabilities right there, and make sure you use the numerical format of the probabilities. That said, 0.1 for 10%, 0.2 for 20%, and so on. Okay, so now let me move on to the next practice. It is about calculating standard deviation based on historical returns. So if it is historical returns, we are treating each return equally. We do not assign different weight like 10%, 20%, 40% weight on different returns. Instead, we're going to treat them equally. So here you have 4 years of data, and each year the return for one individual stock is different. In 2009 it's 30%, in 2010 it's the next 10%, next 19%, 40% in the next 2 years. So how exactly do you calculate the standard deviation using the mathematical formula? So what you do here is first to take the average of the 4 numbers. Okay, so you have 4 returns, take the average, it is going to be 10.25%. And then you are going to use a 30 minus 10.25 to get a 19.75, negative 10 minus 10.25 to get negative 20.25, so on and so forth. So that's called a deviation. And then you're going to square the deviation, alright, take the exponent of 2 to get a squared deviation, and then you're going to add them up to get a sum of squared deviation divided by a degree of freedom, which is n minus 1. N is the number of returns you have here. You have 4 returns, so n equals to 4, so n minus 1 equals to 3. So the sum squared deviation divided by 3 would give you the variance. And then you take the square root of the variance to get standard deviation of 29.10. Right? So that's quite some work, and it's gonna be very time consuming too. So if you use the calculator, it's gonna be much easier. Once again, I'm going to hit the Start button and I'm going to edit. Alright, so since I start a brand new exercise, I need to clear all the previous data. So what I need to do is I just move up, make sure L1 is highlighted, and then I'm going to clear enter. Clear enter. So that's how I clean all the data in this column. And then I move to L2 and make sure I move up. L2 is highlighted, then clear enter. And then to L3, move up, just select the title, clear enter. Alright, now I clean up all the previous traces, so I can start over again. And I'm going to put the return just in one column. So once again, if it is return, you don't have to use the numerical format. You can simply put a -30 for -30%. That's fine. If you do that, then your result will be at the same magnitude. And then put a -10, then -19, and then 40. Okay, that's it. You don't have a column for probabilities because you're gonna treat each of the number with the same probability. So there's no necessity to define probabilities. And then you follow the same step as before. You hit the Stat button again, and then you calculate. You hit one variable stat, and your list is actually in L1. So I'm going to hit second number 1 to choose L1 right here. And then I move down. I do not have a frequency list, so I just clear that one. Okay, hit clear. There's no probability column, and then just to calculate. All right. So as you can see, I have a little different result. So what I need to do here is just to check if my numbers here are correct. So it's actually 30. Okay, so if I want to start over again, then after everything is cleaned up, I'm going to put a 30, okay, enter, -10, enter, -19, enter, 40, enter. It is okay if you use a 30 for 30%, -10 for -10%. If you do it that way, your result will be at the same magnitude. If you do probabilities like the previous exercise, make sure for probabilities 0.1 for 10%, 0.2 for 20% in your calculator. Okay, so basically I just finished editing this column data, and then I don't need a column for probability. I just directly hit the Stat button again and go ahead to calculate. Again, it's one variable stats because this is my only variable to calculate the standard deviation for. Hit enter. And then my list should be L1. Alright, just hit second one, that's L1. And if I move down, there's nothing there. If you had something before, just hit clear. Make sure there's nothing left for frequency list. And then you drag it down, okay, to hit calculate. So that's your result. As you can see, your result is 29.10 as it's calculated here. You also have another result, sigma x. You see this is a Greek letter sigma. That is a 25.2. So you need to be selective and choose the right answer. So under what case do you select 29.1? When this 4 years of return is just a sample of years. It's not representing the entire population. For example, this is a stock may last for 100 years, and you are just to pick 4 years out of 100 years to do the analysis. Then it is using a sample of years. If that's the case, you're going to use n-1 as the denominator, okay, instead of n. So you're going to use a 3 as denominator instead of 4. If your denominator is 3, not 4, then the number should be larger, right? When you have a smaller denominator, the value should be higher. So you should use 29.10, not 25.2. And also, if you have a sample of data, then S basically stands for sample. Just go ahead and pick SX, okay? Because S is sample. So in what case do you use a sigma x? When the 4 years return here is not just a sample, instead it's the entire population of years. Let's say this is a new stock that just lasts for 4 years sharp, and the 4 returns is all the return you can get for the stock. If that's the case, then you do not have a sample, you have the whole population. Then you should use a sigma x. And if you use a sigma x, the denominator here should be n, not n minus 1. Alright, so you should divide the whole thing by 4 and get a smaller number for the standard deviation.